Hey, welcome back to another functional C# video. In this series we're diving into something I teased earlier, a result type or result monad if you're into the FP lingo, called flow. So what is a result type, you might ask? Well, beyond the obvious, a type that holds the result of an operation, it's more useful to think about what a result type does rather than what it is. You write a method, it runs. Sometimes it gives you the value you expect, sometimes it throws an exception, and sometimes it crashes production on a Friday night. But what if your method always returned a result you could actually handle? A result type wraps the outcome of an operation, either a success with a value or a failure with context, into a single return object. Instead of relying on exceptions or magic numbers, success and failures become part of the same type system. In C#, exceptions are often overused. You throw them for logic errors, catch them 12 layers up, or worse, not at all. With a result type like flow, you force every call to answer, did I succeed? If not, what went wrong? And can I retry, continue, or use a fallback value? Let's begin. Flow is available on NuGet. Just search using the text Flow.Core as currently shown on screen. But before we dive in, I want to show you the part of Flow that, at first, you're probably not going to like. But once you understand the power of a result type, trust me, you wouldn't want it any other way. Take a look at lines 16 and 18. These are the two values Flow can hold, a success value or a failure value. But there's a twist. They're both private. That's right, you can't just walk up to Flow and say, hey, give me your value. Instead, you have to provide it with two functions, one to handle success and one to handle failure, and only one of them will get evaluated. And yes, if you really need to, you can ask whether the flow is a success or a failure before providing those functions. But honestly, in over 10 years of using result types, I can't recall a time I had to. Because the beauty of this model is that you can shape your logic mid-flow before you ever reach in to get the value. The value itself becomes almost trivial. What matters is the flow, the structure, the transformations, the intent. Still sounds a bit strange? No problem. The first state with flow is all about how to start a flow and how to respond to success or failures explicitly. Let's talk about starting a flow. Now, 99% of the time you'll be starting a flow somewhere deep in the back-end process, maybe in your application or infrastructure layer, and letting that result trickle down through your app until it's needed. So these first few examples might seem a little trivial, but they're essential if you want to understand how flow behaves in the real world. First up, creating a flow. You can do this explicitly using the static flow success and flow failed methods, or implicitly if the types are declared ahead of time thanks to flow's implicit operators. The local method on line 35 returns a flow of string, and notice how it returns the value without calling any flow constructor at all. That's the implicit operator doing its job. Now let's say you have a non-flow value or method and you want to chain it into a flow-based operation. You can do that using the then extension method. That brings us to something that may feel strange at first, but is one of the most powerful features of using a result type. You can change the type mid-flow. What that means is you might start with a customer, but halfway through the process you need an order or a user summary or even just a string method. That's not a problem because the contents of one flow can be transformed or bound to another flow using methods like map and bind. Now personally, I find map, bind and match a bit abstract when reading code, so instead I lean on all of the extension methods that we'll cover in this series, which wrap those functions in clearer, more purpose-driven names. Under the hood, they still use map, bind and match, but you don't have to think in terms of functors and monads to use them effectively. So now we've got the values in a flow, it's time to talk about how to get them out. In these examples, we're skipping the fun part, where the result flows through your app without ever falling into a try-catch trap, but I covered that in more depth in a previous video. For now, we're mainly using the finally extension method, which wraps the underlying match function. And just a heads up, all of the extension methods you'll see have overloads for both sync and async workflows. You'll notice the functions we pass to finally can be really simple lambdas, like success goes to success or failure goes to 0. That's one of the nice things about result types. They force you to think explicitly about both outcomes, but they don't force complexity. Now here's one thing to keep in mind, and don't overthink this yet, but because flow of t has a single type parameter, both the failure function and the success function must return the same type. The twist though is that you can transform either one as needed. For example, in the implicit failed flow example on line 65, I already knew it would fail, so in the success lambda, which would never run, I returned a string instead of an int to match the return type of the failure lambda, which returned failure.reason. I could have gone the other way too, returned an int from both, or even returned the entire failure object, dependent on what I wanted to surface. In the other examples, you'll see we're converting the failure into an int just to match the success case. But the key takeaway is this: you always control what gets returned as long as both branches return the same type. Let's run the app and verify the results. When it starts, you'll be prompted to pick the number of the example that you want to run. As I continue to add more examples and episodes to this series, the source code will get updated, so feel free to check back periodically or just fork the repo to keep your copy in sync. For this series, I'm also trying something a bit different. Where possible, I'll show both the source code and the corresponding results together in the console window, so you don't have to jump between the files to follow along. And as you can see on screen, all the results came back exactly as expected, with a bit of colour coding thrown in to help distinguish failures from successes. Now let's turn our attention to the two flow extension methods you'll probably use the most, OnSuccess and OnFailure. Today we're just going to look at one specific overload, the version that lets you perform an action or side effect mid-flow without interrupting or altering the flow's result. In functional programming, this pattern is often referred to as a tap, something that lets you peek into the flow to log, validate or trigger a reaction without breaking the chain. We're starting simple, using made-up methods to represent typical tasks, like fetching data from a database or sending an email. Later in the series, we'll move more into more realistic examples where results flow across application layers and processing boundaries. On line 35, we start a flow by requesting the contact with ID 42 from the backend database. If that call is successful, meaning it returns a successful flow of contact, then any chained OnSuccess methods are executed as long as the result remains successful. Likewise, if the result were a failure, any OnFailure methods in the chain would run while the flow remains in a failed state as it continues down the pipeline. In this example, the call is successful, so the OnSuccess method is invoked. We use a lambda to say, take the contact returned from the database and pass that email address into the sendEmail method. Since this overload is for side effect actions, we don't expect a result, and it won't change the current flow. So even if sendEmail fails internally, that failure won't affect the flow. The original result continues unchanged. Don't fret about methods that throw exceptions, we will cover them later in the series. Next, we've changed an OnFailure method, but since the flow is still in a success state, it's simply skipped. Then we call finally to extract the final value or failure, in this case just printing it out. For basic flows like this, I often return null when I don't need a specific value rather than using a null object pattern. It keeps things lightweight and I can just check the final result for null at the end. On line 42 we run the same process again, but this time we request a contact ID that doesn't exist. As expected, the OnSuccess method is skipped and the OnFailure method is invoked instead. Now some of you might be thinking, okay, I get the idea of OnSuccess and OnFailure as tap style actions, but what if I actually want to know if the send email succeeded or failed and take action based on that? One simple way to do that, as shown on line 54, is to use a code block instead of a one-line lambda and wrap your side effects within another flow. In this case, we use a version of send email that returns a flow result. We still chain it using the action based on success. But as this is a nested flow, we can just chain an on failure to it to log any email failure, while continuing to pass along the original result untouched. Let's run the app again and verify the results. And yep, once again, everything behaves as expected. I think that's enough for today to give you a chance to digest the basics. Next time, we'll still use simple placeholder methods, but we'll focus on chaining together flow returning methods, going from one result to another in a fluent, expressive way. If you found this helpful, don't forget to like and subscribe. You'll get notified when the next video drops. All the code is freely available on GitHub. You'll find the link in the video description. The solution will grow over time with multiple projects, but for now make sure the console client is set as the startup project in Visual Studio to follow along. And as always, feel free to leave comments, good or bad, and I'll do my best to respond to questions or feedback. Thanks for watching, and until next time, bye for now.